There's voltage in the air above your backyard right now. Not a metaphor, actual measurable electricity. Tesla patented a device to capture it back in 1901. I built one, and what I found wasn't magic. It was something way more interesting than that. Let me tell you the real problem with off-grid living that nobody talks about. You go down this road thinking you're buying freedom. Solar panels, deep cycle batteries, a charge controller, an inverter, mounting hardware, cables, and that's just to run a basic setup on a small property. We're talking about dropping anywhere from $800 to over $2,000 before you've even turned on a single light. And the moment one component fails, the whole system becomes useless until you replace it. You didn't escape the grid, you just built a smaller, more expensive version of it. Now, not everyone needs kilowatts. That's the thing the industry doesn't want you to think about too carefully. Sometimes all you need is a few milliwatts, enough to run a soil moisture sensor in a field, power a small status indicator, or trickle charge a capacitor for an experimental circuit. For tasks like that, dragging in a full Renogy 100W solar kit feels like using a sledgehammer to hang a picture frame. That's exactly where the idea of a Tesla antenna starts to make sense. Not as a fantasy, not as a replacement for real power, but as a serious question worth asking. Is there any usable electricity just sitting in the air above your land? And the answer is yes, kind of. Here's what's actually going on. On a clear day, the atmosphere above the ground carries an electric field roughly 100 I for every meter of height. That's not a fringe number, that's textbook atmospheric physics. You've got a natural voltage difference between the sky and the earth. Scientists call it the atmospheric electric field, and it's been measured and documented So you'd think, just stick a metal plate up in the air, ground the other end, and you've got electricity. And when you actually do it, when you hook up a fluke multimeter and watch the numbers, you do see voltage, real voltage, sometimes dozens of volts, depending on conditions, height, and humidity. Here's the part where most YouTube videos quietly cut away. Voltage is not power. Voltage without current is like water pressure in a pipe with no flow. The atmosphere gives you the pressure, but the actual current available from this kind of setup is incredibly small. We're talking picoamps per square meter under fair weather conditions, not milliamps. Picoamps. Which means the moment you try to connect anything, an LED, a small motor, a USB charger, the voltage collapses. The source simply can't push enough current to do real work. And that is the honest starting point of this whole experiment. Not free energy forever, but there's something real here, and the question is what it can actually do. Here's the thing about Nikola Tesla that the internet completely distorted. He wasn't a wizard. He wasn't a martyr suppressed by big energy. He was an extraordinarily precise engineer who filed detailed patents. And one of those patents, US 68557A, granted on November 5th, 1901, describes exactly the kind of device we're talking about. A receiving plate exposed to radiant energy connected through a capacitor to a ground terminal with a local discharge circuit that fires once enough charge is built up. Read that again carefully. It's not a generator, it's a charge accumulator with a discharge trigger. Tesla wasn't describing a machine that pumps out continuous power like a wall. He was describing a system that slowly collects charge from the environment, whether from solar radiation, atmospheric electricity, or both, stores it in a capacitor, and then releases it in a controlled burst. The distinction matters enormously because the entire free energy myth on YouTube is built on ignoring that one detail. People see the patent, they see Tesla's name, and they assume the suppressed secret is kilowatts. It's not. The honest version of this patent is far more interesting than the myth because it actually works, just not the way the clickbait crowd wants it to. So, what does work? The principle is real. Between the upper atmosphere, specifically the ionosphere, and the Earth's surface, there's a lightning bolt has around 300 million V, but that 9V battery can run a smoke detector for a year, while a lightning bolt lasts about 200 microseconds and can't charge your phone. Voltage alone tells you almost nothing about usefulness. The atmosphere gives you voltage, somewhere between 50 and 200 V on a calm, clear day, depending on height and local conditions. That part is real and reproducible. But the current density in fair weather, as measured repeatedly in atmospheric science research, sits around 2 PA per square meter. A square meter of receiving surface gives you 2 PA. A 10 SQFT plate gives you a 10 SQFT plate, gives you roughly the same order. That is not enough current to light even the most efficient micro LED directly. What it is enough for is charging a capacitor slowly. This is where Tesla's actual patent logic becomes practical. He didn't design a flow-through system. He designed an accumulate and release system. You let the capacitor sit connected to the antenna and the ground for an extended period. Charge builds up. Voltage on the capacitor climbs. At some threshold, a discharge event happens through a local circuit. Then the cycle starts over. The test that actually tells you something isn't, does it light a bulb right now? The test is, connect a capacitor with a known rating, something like a 1 UF cap rated for 400 Vi between the antenna and the ground rod, and come back in 15 minutes. Check the voltage across it with a high impedance meter, like the Fluke 87V, which has a 10 mAh input. If the voltage climbed from 0 to even 5 or 10 V in that window, the system is working exactly as physics predicts. That's not a failure. That's the whole phenomenon. One more thing to watch for, and this trips up a lot of builders, is false readings from inductive interference. If your antenna is within a few hundred feet of power lines, a generator, an inverter like a Victron or SMA unit, or even a long run of a 120 volt extension cord, your meter will pick up induced AC voltage that has absolutely nothing to do with atmospheric electricity. It'll look like your system is working great. It isn't. It's just noise from the grid bleeding into an unshielded conductor. The fix is simple. Test in an open field away from structures with the nearest power source disconnected. If the reading holds, that's real. If it drops to nothing the moment you move away from the house, you are measuring your neighbor's wiring, not the sky. That distinction, real signal versus induced noise, is what separates a legitimate experiment from a convincing-looking video that proves nothing. All right, let's actually build this thing, and the first thing I want to say is the part that matters most is not the part you'd expect. Everyone obsesses over the antenna. Bigger plate, higher pole, more surface area. That thinking isn't wrong, but it's also not where most builds fail. Most builds fail at the insulation and at the ground. Fix those two things first, and everything else becomes easier to evaluate. Here's the full parts list for a first honest prototype. Nothing exotic, nothing that requires a specialty supplier. For the collector, you want a flat metal surface. An aluminum sheet from Home Depot works well, roughly 2 feet to start. A sheet of galvanized steel, an old baking pan, or even a metal window screen stapled to a frame will do the job. The geometry matters less than the surface area and how cleanly it's isolated from everything below it. For the mast, use a dry wooden 2x2 cut to about 8 to 10 feet. A scheduled 40 PVC pipe from any hardware store or a fiberglass rod. The keyword is dry. Wet wood conducts. A mast that's been sitting outside in the rain will bleed your collected charge straight into the ground before it ever reaches your capacitor. Let it dry out fully or use PVC. It costs almost nothing and doesn't absorb moisture. The wire connecting the plate to your circuit. This antenna will not charge your Tesla Powerwall. It will not run your well pump. It will not power the LED lights in your greenhouse overnight or keep a jackery topped off for weekend use or replace a single 100W Renogy panel. If that's the goal, this is the wrong tool. And knowing that is actually valuable information because it means you don't waste money chasing a solution that physics won't allow. What the system can genuinely do falls into a much smaller but still real category. The most honest first application is atmospheric monitoring. If you've got a calibrated setup, known plate size, known height, stable ground, no interference sources nearby, the voltage your capacitor accumulates across a consistent time window tells you something about the electric state of the air above your property. Before a weather front moves in, the atmospheric electric field changes. It compresses. It intensifies. It shifts in ways that a well-documented baseline can actually reveal. That's not pseudoscience. Meteorologists and atmospheric physicists have been measuring this for decades. Your setup won't match a no AA instrument, but it can give you a repeatable local signal if you're disciplined about logging it. The second real application is in the micropower range, and this is genuinely the frontier worth paying attention to. Certain low-power wireless sensors used in agricultural settings operate in the range of 10 to 100 microwatts in sleep mode. Soil sensors, gate position indicators, frost alarms, tank-level monitors. Some of the newer ones from companies like Monit or Dragino are designed specifically for energy harvesting scenarios where continuous power isn't available. Could a well-optimized atmospheric collector, larger plate, better ground, cleaner insulation, accumulate enough charge over hours to trigger a capacitor dump that fires one of these sensors? Possibly. Not reliably. Not yet at small scale, but it's a legitimate area of low-power electronics research, not fantasy. The third use is educational, and don't underestimate it. If you've got kids, apprentices, or just a genuine interest in understanding energy from first principles, this experiment teaches something a $400 solar kit never will. It forces you to distinguish voltage from current, accumulation from generation, natural phenomena from marketable myths. One afternoon with this setup teaches more practical electrical intuition than 6 months of reading about it. Here's a comparison worth internalizing. A 100W solar panel from Renogy on a sunny day in Kansas produces around 400 to 500 W hours. A small wind turbine on a decent afternoon might do 200. A quality lithium battery from Battleborn stores 1,000 W hours and delivers it on demand. Your atmospheric antenna, running all day with a 1 square foot plate at 8 feet, accumulates charge in the range of nanowatt hours. The scale difference isn't a reason to dismiss the experiment. It's the entire lesson. The farmers and off-grid builders who get the most value out of their energy setups aren't the ones who found a secret source. They're the ones who got precise about scale. A pump needs 500 W, a sensor needs 50 microwatts. Treating those two problems the same way is how you end up with a $2,000 system doing a $15 job. That's the real output of this experiment, not the charge in the capacitor, the clarity about what each task in your operation actually requires, and which tool honestly fits it. Once you have that, every purchasing decision gets sharper. You stop buying mythology and start buying what matches physics. Here's the takeaway that nobody in this space wants to say out loud. The most valuable thing this antenna produced wasn't electricity, it was a filter. One honest experiment with a metal plate, a ground rod, and a capacitor is enough to make you permanently immune to an entire category of nonsense. The free energy box sellers on Amazon, the YouTube channels with 40 million views showing a glowing bulb with no explanation of where the actual current is coming from, the $300 kits promising to cut your Duke energy bill in half by harvesting ambient electromagnetic energy. All of it fails the same test this antenna just passed. Measure the current, measure the power, test it under real load, log it over